Good morning, guys. We are now on section 1.7 in our Algebra 2 book. It is very early in the morning, so since I'm recording this very early in the morning, I bet you guys are going to get up and you're going to work on it very early in the morning as well, right? Okay, before we get started, I wanted to ask you if you knew what it was that chickens brought to picnics. Well, picnics, birthday parties, whatever, chickens always bring cupcakes. So, yes, you do have to remember it's very early. So that is even more lame than I might typically do. So we're just going to go ahead and go through section 1.7 on this video. And all this is more factoring, which is what chapter 1 does lots and lots of. Simply factoring, if I can simply get to the right page. Okay, that's page 34, that's page 31, page 32. And this is a special technique that we're going to be talking about now. It's called factoring by grouping. And this may be a pretty new concept to you. I don't remember us covering it much at all in Algebra 1, but it's not a difficult thing to do. Polynomials with 4 or more terms may require a special technique called factoring by grouping. When applying this method, the distributive property is used to factor out common binomials. It's sort of like taking the distributive property in reverse. It says, remember that factoring means writing the original expression as a product. This means that if we have something that looks like this, we have x times the quantity. Oh no, that's just not the right color. See, look how dark green that looks in this strange color. X times the quantity x minus 7 plus 5 times the quantity x minus 7. That's not in factored form because what we've got is the expression right here is the sum of two products. We've got a common factor, so we have to remove that common factor out. Now you can multiply it out and factor it by trial and error, but whenever you have something that looks like this, you remember that a common factor is anything that's that's included inside the parentheses. So we have a common factor here of x minus 5. If we remove the common factor, I said x minus 5, I mean x minus 7. We remove that common factor, and then inside this second set of parentheses, what do we have left? When we factor out x minus 7 from this first product here, only thing we have left is x plus what? Well, we've taken the x minus 7 out here. We have a positive 5 that remains. So what we've done is we've factored, and we see this common group. I don't know that I'd call it a group, but we see that we have a common binomial factor here. Once we remove that, x minus 7, we have all that we have left is an x plus 5. So, there's another thing that we're going to use when we're factoring by grouping, and it's going to use the associative property to group the terms of a polynomial together so we can get a common binomial factor. So let's go ahead and get me room here and try example 2 in our book. This example 2 says factor the following. We're going to factor ax plus 3a plus bx plus 3b. Now let's look and see what we might have in common. We've got two a's, two x's, two 3's. Ah, you have two a's, two x's, two 3's, and two b's. So now we have to decide how we're going to group these things together. Remember, the associative property tells us that if you have three terms that you're adding together, it doesn't matter how you group them, which two you decided to group together. They have the same value. So when we're factoring by grouping, we're going to create our own little binomial expressions here. So what we want to do is group together terms here that have common factors. So why don't we just do ax plus 3a we can group together. Bx plus 3b we can group together because we have common factors here of a, common factors in the second expression of b. We're going to do this distributive property in reverse. A is the common factor. When we take that factor of a out, we have x plus 3 remaining. So this is why I say we have the distributive property in reverse, because here, if we distribute a to the x and the 3, you have a times x is ax, a times 3, positive a3. So what we've, positive 3a. So what we have done is we've used the distributive property here in reverse. So what are we going to be able to factor out in common here? We have this factor of b that we remove, and we have x plus 3. Aha! Now you see where you're going. We have a common factor that's enclosed in parentheses. So we want to remove or factor out this common factor of quantity x plus 3. What do you have left? Well, we've removed the factor of x plus 3, and we have a plus, we remove the factor of x plus 3 over here, a plus b. So the factored form of this is x plus 3 times the quantity a plus b. Okay, let me write this over here at the side. X plus 3 times the quantity a plus b. Now let's see, we just grouped these the way they came, and we ended up with common factors of a and b. Well, what if we had chosen to do, where did I put this? What if we had chosen to do that grouping differently? What would happen? Well, if we don't get this answer over here, we've got a real problem, don't we? So let's just group this differently. I'm going to remove my parentheses and see how I might wish to group it this time. We have A's in common, we have B's in common. What else do we have? We also have 3's in common. We have X's in common. So why don't we I'm just going to go ahead and rearrange this. I'm going to say that we have AX plus BX that I'm going to group together because we have a common factor, plus 3A plus 3B because I have a common factor of 3. I factor out the X. What do I have left? A plus B. Plus, what do I factor out here? Factor out the 3. Remaining inside the parentheses, I have A plus B. When we did it the first time, the factor that we had in common enclosed within the parentheses was X plus 3. This time it's A plus B. when we factor out a plus b, make sure that you close that in parentheses. What do you have left? X plus 3. Now compare these two factored forms. Quantity x plus 3 times quantity a plus b. The order is different here. Quantity a plus b times quantity x plus 3. But these are the same because we learned that with multiplication is commutative. It doesn't matter what order you multiply factors in, you're going to get the same product. So this is a perfect example shown both ways of how you're going to be able to factor by grouping. So now, let's see what I can do. Let's go ahead and look at example number 3. Let's see what we have. X cubed minus 3x plus 5x squared minus 15. So we're going to want to group these together as with common. Going to group the terms together binomials. Here we've got a factor of 5 in common. Here we have a factor of x in common. Let's see what happens if we group these two together and we group the 5x squared minus 15 together. What factor do we have in common? Only a single factor of x. X times the quantity x squared minus 3. You can check it by going back. Have x times x squared is x cubed. X times a negative 3 is minus 3x. Here, there are no factors of x in common, but there's a factor of 5 in common. 5 times x squared minus 3. The quantity x squared minus 3. You distribute to check. 5 times x squared is 5x squared. 5 times the negative 3 is a negative 15. We have a common factor of x squared minus 3. So we factor out x squared minus 3 because this whole expression, the x squared minus 3 is the factor. You've got to make sure that you have that enclosed in parentheses. So you have x squared minus 3, the factor that you have left remaining here in this first product is x, plus the factor that's remaining here is 5. X squared minus 3 times x plus 5 is the solution. Now, let's see. X squared minus 3. We learned about a special product that was the difference of two squares, x squared minus y squared. If you had a binomial and both of the terms were perfect squares, you could factor it. Is 3 a perfect square? No, 3 is not a perfect square. So the quantity x squared minus 3 times the quantity x plus 5 is all the further that you are able to factor this expression. Let's go on and do example number 4. We have x squared plus 2xy plus y squared minus 4. Now, this one is pretty much an Algebra 2 problem, not an Algebra 1 problem. Okay, hang on for the ride on this one. first, what we have here, x squared plus 2xy plus y squared, that is a perfect square trinomial. And the perfect square trinomial is a special case, square trinomial, special pattern, that's trinomial. You just simply have to recognize the pattern, and with perfect square trinomials, you have the first term is a square, the third term is a square, and the second term is twice the product of the square root of the first term, square root of the last term. And we talked about this at length in the last video. The square root of x squared is x, square root of y squared is y, 2xy is twice the product of the square roots. So this right here is a perfect square trinomial, so we're going to group it together as a trinomial. We're going to use our rule that a perfect square trinomial, the sign of the central term, the second term in the trinomial, is the same as the sign in the binomial factor that you're going to square, that you're going to use twice. So x plus y squared is factored form of this. And let me verify it for you just in case you're saying, I haven't quite caught up to that yet. Let's go ahead and use x plus y as a factor twice. When we FOIL, our first term is x times x, or x squared. Our outer term, the partial product there, is x times y, plus the inner partial product, y times x. I'm going to put that in alphabetical order. The last term, partial product, y times y, is y squared. You combine the like terms, x squared plus 2xy plus y squared. Exactly what we have here, x squared plus 2xy plus y squared. So first you had to recognize that this was a perfect square trinomial, and then you had to know how to put that into factored form. And then let's see what we have. Another little quirky thing. X plus y, quantity squared, minus 4. This doesn't look or may not look like a binomial to you, but it is, because it's this first term squared minus the second term. What do you notice? We have the first term squared minus a second term squared. This expression here is the difference of two squares. Remember, the difference of two squares, the first term is a square, the second term is a square, and we're subtracting. That makes it the difference of two squares. And the way that you factor this, to factor the difference of two squares, is it's the sum of the square roots of the terms times the difference of the square roots of the terms. A plus b times a minus b. This is a little different though. What is our a equal to here? Well, our a is actually x plus y, and our b is 2. So let's use our pattern. A plus b, a is x plus y. That's a plus b, x plus y plus 2 times the first term, x plus y minus 2. And believe it or not, you go ahead and multiply this out, you are going to come up with this original product here, or with this original trinomial here. Now, if you get to this on a Tuesday or at home, or you watch the video and you say, okay, well, let me go ahead and multiply this out and make sure I get what I'm supposed to get. If you have difficulty with this, write a note and ask me about it the next time I see you, okay? I want to do one final example from this section, but first let's look at this again. This involved all sorts of different jobs here. First you had to recognize, that's really pitiful. First you had to recognize that you had a perfect square trinomial. You had to group it together. You had to know how to factor a perfect square trinomial. That the sign here is positive because the sign in front of the second term of the trinomial is positive. And then you have to recognize that what you actually have here is the difference of two squares. Once you recognize that you have the difference of two squares, which is generalized as a squared minus b squared, you have to know how to factor the difference of two squares. A plus b times a minus b. And then you have to remember that this first term that you have, the square root of the first term, actually is a binomial. So it becomes x plus y goes in anytime you have the a. So that's how we end up with x plus y plus 2 times x plus y minus 2 when you're factoring this difference of two squares. That's why this looks so very much different than, for example, if you had x squared minus 4, that would be x plus 2, x minus 2 in factored form. And this is what you're used to the factorization of the difference of two squares looking like. Something like this. This is also the difference of two squares. So, we have one last example that I want to do, then I think I'm going to call it a night. See what I have here. We have 3y cubed plus 6y squared minus 27y minus 54. Whoops, I guess I should put in the minus 54. Now, we haven't had any common monomial factors, but here we have a 1, 2, 3, 4 term polynomial, and there's no common factor of y. However, there is a common factor. Let's look at 3. Is 3 a factor of 6? Yes, 2 times 3 is 6. Is 3 a factor of 27? Yes, 3 times 9 is 27. And we know that 3 is also a factor of 54 because we're going to remember our little cheat, if you will, that how do I tell if a number is divisible by 3? If I can sum up the digits in here, 5 plus 4 is 9, and if I can take that sum, 9, and if I can divide that by 3, which I can, 9 divided by 3 is 3, then that number right there, the 54, is divisible by 3. So first we have to factor out 3. We have 3 times the quantity y cubed plus 2y squared minus 9y minus 18. I think is what we have. Now, let's group the terms together. We already have a factor here. How do I want to do this? Well, I see that 9 and 18 have a common factor of 9, so we still have that 3. That's why this is a good example of why I say begin your problem at the left and write from left to right. So we're going to have 3 times quantity y cubed plus 2y squared minus the quantity 9y plus 18. Hit pause, look at this. Make sure you see what's going on. When we add the parentheses, it has to be minus 9y plus 18 because we have to distribute this negative sign. Negative 1 times 9y is negative 9y. Negative 1 times 18 is a negative 18. Now, let's see what we have. So, we're going to say 3. We're going to have to do some factoring of common monomials out, so we better put in an extra bracket here. This is very definitely an Algebra 2 problem, not an Algebra 1 problem. What factor do we have here in common? We have a y squared. If we factor out a y squared from y cubed, y squared times what is equal to y cubed? Y squared times y is equal to y cubed. Plus y squared times what will give me 2y squared? Well, 2. Y squared times 2 gives me 2y squared. Now, what factor do we have in common here? We have a factor of 9, don't we? Let's see what they're doing. Okay. We pull out this factor of 9. What do you have remaining? 9 times what? Gives us 9y. 9 times y. Right there. 18. Negative 9. But we're just going to say negative 9. We have this factor in common. We have a factor of 2 remaining. Because this will yield, the opposite of negative 9 is negative 9y. The opposite of 18 is the same as negative 9 times 2, which is negative 18. Now you see we have this common binomial factor in there. So we're going to have 3, and then in parentheses, can we still see it? Yeah. We're going to take out that common factor, that common binomial factor, y plus 2 times, what do we have left? Y squared minus, we factor out the y plus 2, we have the negative 9. Are we done yet? No, we're still not done. Y plus 2 you can't factor, but y squared minus 9, that's the difference of 2 squares. So you have to recognize the difference of 2 squares. 3 times quantity y plus 2. Now we're going to factor this y squared minus 9. We have y plus 3 times the quantity y minus 3. Anything we can combine in here? Anything that we have in common? No. We're completed. And at this point, our little bracket becomes redundant or unnecessary. So we actually have 3 times the quantity y plus 2 times the quantity y plus 3 times the quantity y minus 3. Go back through, multiply all of this together, and you will end up with the original expression. A key thing to remember here is don't forget to carry your factor of 3 down into the final answer. Okay, that's the end of the teaching for section 1.7, and we'll see how things go in class. I'm glad that you guys are with me, and I'll have another lame joke for you very soon.